So we're doing a couple more days of word problems today and tomorrow. We're introducing a new type today, but after that, it's pretty much just mixing all the types together and practicing. And then that's it for the unit. So Monday, Tuesday will be kind of review, and then probably Wednesday of next week will be our test, okay? Today we're not learning a new skill. We're just, we have part of this question is a little bit different from anything we've done. All the skills, all the math involved, we've done, okay? Lots of it. So we should be pros at all the math part. It's just understanding what the question is asking us to do and understanding kind of how to get started or what strategy to take. That's a big part of today. And then at the end of this lesson, there's an example where we're going to compare different kinds of questions and think about what strategy we would take for each of them. Okay, so if you are ever stuck, like we're going to go through it today, but the end of this video would be a good one to go back and rewatch and think about if you have time or if you're not doing anything in MSIP. It'll only be like 5 or 10 minutes long. You don't have to watch the whole thing, right? Just skip to the end and watch where we look at 6 different questions and kind of take a look at how would you solve this one? What kind of question is this one? What kind of question is this one? That's a big part of today as well. Okay, so let's get started. So at first glance, this looks similar to what we were doing yesterday because it's a question where you are given the equation. Okay, and that is important to note. Whenever I'm given the equation like this and it's talking about a ball being thrown or a ball being kicked or a rock being tossed or a rocket is shot or a cannonball is shot or some object flying through the air, I always sketch it and think about the sketch. So we're going to start with that. Here's my sketch, and it's thrown off a cliff, so it kind of goes off the cliff and goes like that, right? And then the parabola would continue, but the real world only occurs in this positive part because this question is about height, which is going to always be positive, and time, which is going to always be positive. You could do a question where it's the height of a bridge, and we call that height 0, and you throw something up in the air, and then when it passes the bridge and goes into a ravine or something, that's like a negative height. Like you could kind of talk about that, you know what I mean? But often for these height questions, 0 is the ground. So like the rock or ball or whatever doesn't go below the ground, right? So once it hits the ground, it's over. All right, so this is different from anything we've been asked. We've done math questions involving this, but we haven't done a word problem involving this. So the first question, what is the maximum height of the ball? We have to ask ourselves, where in the graph does that occur? What's important about that? And how do I find it? Those are the questions that we ask ourselves that goes through our head. So who has something to say about that? Ziggy, what do you think? The maximum height would occur at the vertex. Very nice. So here's my vertex. So for question A, see, I wouldn't normally do this. This is just for the lesson, but I'm going to even label my graph with part A is finding this point. Okay, and we'll do the same for B, C, and D. Okay. And the maximum height I'll read off of this part, like that axis right there, right? The scale along H there. How do I find that? Okay, so it occurs at the vertex. That's what happens. How do I find the vertex of this equation? Because it's not given to me. Jaden? Put it in vertex form. Do we know how to do that? Does anybody remember what that process is called? What's it called? Oh, don't remember? Who remembers? It's funny. So I remember when I taught you this, I said, go ahead. Completing the square, that's right. We like to know it by name because then once I say completing the square, you go, oh yeah, I know how to do that, right? Put it in vertex form by completing the square. That's what does that. So exactly. So let's make a little note on that. So for A, we're going to find the vertex by completing the square. That's our explanation. Again, you wouldn't normally write that down. This is our note to ourselves. This is how you do it. Whenever it says max or min, this is what we're going to talk about later. Whenever it says max or min of a quadratic, that's the vertex. So I have to find the vertex. How do you find the vertex? By completing the square. Always do it that way. Right? There is another way of doing it, by the way. We'll talk about that, but we haven't seen it yet. Okay. Completing the square is probably the easiest anyway. So let's go ahead and do that. So go ahead and try. So first of all, I'm going to factor that out, right? I'll get you started, then I'm going to let you keep kind of going. So I factor the negative 4.9 out, and when I take, it looks like it's going to be messy, like, oh, look at all these decimals and negatives, and negative 4.9, what in the world is that? But when I do 19.6 divided by 4.9, I get 4. So it's going to turn out nicely. Okay, so now you're finding that number that turns it into perfect square trinomial, so go ahead, continue, try. See if you can keep going. How do you find that number? Remember, there's a little algorithm to it, a little trick. Who remembers, who doesn't remember? It looks like a lot of people don't remember. This was not that long ago. That's your b. Take it, divide it by 2, square it. Isn't that what you do? Right, 4 divided by 2 is 2. Plus 4 minus 4. Yes? This is completing the square. Are we still stuck on completing the square? So remember, I have to do, I take my b, which is this, negative 4. I divide it by 2, which is 2, and I square that, which is 4. So plus 4 minus 4, right? Plus 5.4. Okay, it sounds like it's starting to click for people. Negative 4.9 t squared minus 4t plus 4. And then, watch if you want to, when I take the negative 4 out, I have to multiply it by 4.9. So 4.9 times 4, whoops, and it's negative, right? So, oh no, it's 2 negatives, so it's positive. That's important. If I got negative, then that would have really messed up this question. Negative 4.9 times negative 4 is plus 19.6 plus 5.4, negative 4.9. And then how do I write this? T minus 2 squared, and it works out to plus 25. So it worked out really nicely. Is everybody okay with that? Forgetting how to complete the square. If I had negative 19.6, this is what happens. Like if you just mess up one little negative, then all of a sudden, like the maximum height of the ball is a negative number. It's below the ground. That wouldn't make any sense. The nice thing about word problems is you would say, well, wait a minute, that doesn't make any sense. So either Mr. Belair messed it up and made a bad question that doesn't make any sense, or you missed a negative somewhere where like you made the mistake, right? So one or the other. So you got to think about that. Okay, so let's interpret these results. I've got a vertex of, this is a shift to the right by 2, so 225. Some people find these word problems hard where we're maximizing and minimizing because the solution is not quite as forthcoming, I suppose. All the other word problems we've done, you get to the end and you get x equals 5 and x equals negative 10. Right? Like it says x equals. These questions don't say that. I'm left with an equation that I have to interpret. So write out the vertex, and if you want to watch This is the max height, the y value of the vertex, and this is the t value where the max height occurs. T equals 2 in this case. So there's 25, and there's 2. So t is 2, h is 25. This question's asking me about h, so therefore the max height is 25 meters, I believe. Yes? Well, if you look at this equation, it's t squared plus 19.6t. That's like x squared plus 19.6x, right? So input output variable, like this is always going to be my y, and that's always going to be my x. That's kind of always how you do it. But if you think about it, if you think about dependent and independent variables, you talk more about that in science class, but you should talk about that in science class, and we can talk about that a little bit too in math. Like the independent variable always goes on the horizontal axis. So time moves independently of the height of the ball. Time just moves. And the height of the ball depends on how much time has elapsed, right? So it's the dependent variable. Okay, B. How many seconds did it take for the ball to reach the maximum height? Can somebody answer this for me? Liam. 2 seconds. We've already done all the math, so we just answer it. It took 2 seconds. Liam, are you okay over there? To reach the max height. So no more work needed. 2. So there's our question B right here, right? B was already done. C. How high is the cliff above the ground to 1 decimal place? Look at the graph. What is that? Where does that occur? Rachel? Oh, no. Zoe, do you know? No? Riley? The y-intercept or h-intercept, the vertical intercept, exactly. Very good. Yep. So here we go. There's C. How do I find that? This is why we want to graph it. This is why you want to sketch it this way and think about the graph. Where does this occur on the graph? Jaden? Yeah, so make a little note to yourself. Find h when t equals 0. I just sub 0 in. I could use either of those equations. I'm going to use the first one, but I could use this one too, right? So h equals negative 4.9 times 0 squared plus 19.6 times 0 plus 5.4, was it? And so this is 0, this is 0, and this is an easy question. Therefore, the cliff is 4.5 meters high. Yeah.
I didn't know they took 2 seconds to reach the maximum height.
Because this tells me the x value or the t value when the maximum height occurs. So it's right there as part of your vertex. Okay, last question, D. Where does D occur? Go back up to our sketch. People are very hesitant to sketch these, but it helps so much if you and at first it might feel weird, but trust me, if you can get good at sketching like this and using a sketch to solve these problems, oh man, are you going to be good in grade 11 and grade 12? It's so useful. Riley. Nice. There's my answer to D. So you're going to make H equal 0. Awesome. Find t when h equals 0. This is stuff we did a couple of units ago. Right? So we know how to do this. Now, when we did this a couple of units ago, we didn't have all the skills we have now. Now we can factor and use the quadratic formula to solve these things, whereas we couldn't back then. Okay, so 0 equals negative 4.9 t squared plus 19.6 t plus 5.4. And I'm going to go ahead and guess that this is not factorable and just use the quadratic formula. But put your pencil down and listen for a minute. Notice something that happened. In question A, we completed the square, found the vertex. Now we're solving by factoring. And see how they answer two very different questions. The first question, what is the maximum height of the ball? When you see the word max or min, complete the square, find the vertex. How many seconds does the ball hit the ground? I'm factoring, or quadratic formula to solve that one. But if you don't know what skill you use, if for A, you try to factor, or for C or D, you try to complete the square, you're going to be lost. So that's what I mean by a big part of today is what skill do you use when? You've got to be able to read these questions and know what to do. And we'll look at that. We're going to do one more example, and then we'll talk more about that. All right, so here we go. T equals negative b plus minus b squared minus 4ac. And a is negative 4.9, b is 19.6, c is 5.4. All right, let's see. 19.6 squared. Worked out to 490, which is not a perfect square. And I'm just going to evaluate these on my calculator. So we, like again, in word problems, quadratic formula, we do not worry about exact answers. We're looking for a decimal here. Negative 0.26 and 4.26. Now what do I do with these? Yep. Very nice. You want to watch for a second? So what is that negative 0.26? That's this. Which makes sense. It's very close to the vertical axis. That's usually how these things work. And then the ball or the rocket or the rock or whatever is shot far away. So the other intercept usually, not always, but usually is kind of way further away. So in this case, 4.26 seconds, right? Therefore, it took 4.26 seconds to hit the ground. Or it was in the air for 4.26 seconds or whatever. Any questions about that? That's a nice one because it's kind of got every type. It's got the quadratic formula. It's got just subbing in and solving. It's got the maximize, minimize, and interpreting the vertex kind of thing.
Isn't it quite weird that the number, not negative, but the number is so low that it's unmissable?
Alan, anything's possible. You could come up with a question where that's absolutely true.
So 0.0001, like
It depends. Yeah, it wouldn't even just be because the number's so small. It would just have to do with the question. Yeah, absolutely. It's possible. Just like we saw one where the number was too big that it didn't make any sense. But it's not like the number was in the billions. It was just 20. But it just didn't make sense as an answer.
I go, when can actually get too big?
Well, you'll have to look back at those lessons. It was a couple of days ago we saw one like that. Okay, one more. This looks familiar, I hope. The sum of two numbers is 26. The sum of their squares is, but instead of giving us the amount, it says a minimum. And when that happens, we're not factoring, we're not using the quadratic formula. It says minimum, so we're finding the vertex. That's where the minimum of a quadratic occurs. This will form a quadratic relation, and if we want to find the minimum value, then that's where we find it. These questions can be different because a lot of people don't understand what it is we're finding. Somebody was asking about that this morning. So we're just going to solve it and not worry about that. But when we have our solution, after we've found our solution, I think it'll be easier to understand exactly what it is we're finding. But even if you don't fully understand it, solving these is always the same thing. You always can kind of work through it. Okay, so what do we start with? Let x. Why didn't we do this? Let x represent in the first question. Because it tells us what h and t are. Gives us the equation, tells us what h and t. H is height in meters, t is time in seconds. Those are your let statements. So why would we redo it, right? So this one doesn't. So let x represent one number and let y represent the other number. So what do I know about x and y? X plus y is 26 because the sum is 26, which means y equals 26 minus x. Is that right? Happy with that? Okay with that? That's like when we're doing those perimeter questions and we do that first little part where we use the perimeter to come up with, right? Same idea. If it says the difference of two numbers is, then you would do the same thing, but it wouldn't be x plus y, it'd be like x minus y or something like that, okay? The sum of their squares is a minimum, so I'm just going to use m for minimum. Doesn't matter what you pick here. And again, this is different from the ones we've done. The minimum of the sum of their squares, x squared plus y squared. But that's x squared plus 26 minus x squared, because that's my y squared. We are finding the minimum value. So what I need to do is expand and simplify, but not move everything to one side and set it equal to 0. Expand and simplify, and then complete the square. So this is x squared plus, oh boy, what's 26 squared? 676 minus 52x plus x squared, which is 2x squared minus 52x plus 676. Okay, I'm just going to go through this one quickly. You'll get lots of practice when you start the work. Factor out the 2. 26 divided by 2. Is everybody with me here? 13. 13 squared, 169. So plus 169 minus 169 plus 676, which equals 2. X squared minus 26x plus 169. 2 times negative 169, just use your calculator, it's negative 338. X minus 13 squared plus 338. That is a 6, 8. Like if that was fast, don't forget a week or two ago, you were awesome at this. You know how to do this, okay? Completing a square, we know how to do that. But what does it mean? Sakira. It's the minimum value. It's the minimum value of the parabola, and it's where it occurs. So this is what I always do. I always write down the vertex. And it's interesting. In this case, the 338, we don't need that. It doesn't help us. It wasn't asking for the minimum value of the sum of the squares. It was saying what numbers. So this is actually m. It's not y, which is a little bit confusing. Maybe I should use a and b or something. And this is my x. So x equals 13. Y, remember, is 26 minus x, which is 26 minus 13, which is 13. Therefore, the numbers are 13 and 13. But then people I know are asking themselves, so I'll let you get that copy down, but people are asking themselves, what numbers? What in the world did we just do? I don't even understand. Like, I understand all the math, but I don't really understand what it is that we just did. So we started with, so put your pens down and just watch. We started with the sum of two numbers was 26. There was that, and we got that. It said the sum of their squares is a minimum. So I took the sum of their squares, and I found where the minimum of that would occur. We know a lot about quadratics. This quadratic, if I look at this last step, it opens up because that's positive, and it has a vertex of 13 and 338, so it would go up from there. That's what that parabola would look like. The minimum value, which the question didn't ask anything about that, but it was 338, and it occurred when it was 13. But what is this question exactly talking about? What in the world are we doing here? Here's all the list of numbers that add up to 26. 1 in 25. Do you agree that's 26? Does anybody disagree that 1 plus 25 equals 26? Would you like to form an argument for that? Okay, good. 2 plus 24, does that equal 26? 3 plus 23, 4 plus 22. Here's the squares of those numbers in the orange column, which looks kind of brown on the screen. Okay, so 25 squared is 625. 8 squared is 64. You can see them all 100, or 10 squared is 100. Do you see that? You agree? These are the squares. And here's the sum of those squares. Do you agree with that? 1 plus 625 is 626. 4 plus 576 is 480. Get that? Have I lost anybody again yet? I don't know if I can be able to grab that. So what does this mean? Take a look at all of these sums. They're getting smaller. 538, 500, 546, 43, 10, 388, getting smaller and smaller and smaller. And take a look at this. 346 at 11 and 15, 12 and 14, square them both, and I get 340. Whoops. And 13 and 13, 169, 169, 338, and then it starts getting bigger. That's all we found. These are all the combinations of numbers that add up to 26. If I square them and sum them, I have an infinite number of combinations of numbers that would happen with. Watch, I could, like this is, I don't know if you've ever used Excel, but look at, I can keep going and going and going and going and going, right? And get a whole lot of, so I stopped eventually, but a whole lot of pairs, and they can get really big eventually. We just found the minimum one, right? I mean, it's just a math class word problem. That's all this is, right? But that's what we were doing. Well, this relationship would not have a maximum. So you don't have to worry about whether it's a max or a min. The question defines that. So if it's a maximum value, the question will say, what is the maximum? If it's a minimum value, it'll say, what's the minimum? You just find the vertex. Okay. All right. You do not have to write this down. I don't think you want to write all of these down. You can look at it on the classroom later, but you really do want to pay attention to this because this is tricky for some people. If you have to, we're going to be done soon. But if you have to, you can. But You want to see this, I think. Two numbers have a difference of 14. The sum of their squares is 240. What are the numbers? How do I do this question? What do I do? Which kind of question is this? Yeah, it is. What else? Am I going to complete the square? Kristen, what do you think? No idea? It's hard. Okay. You're going to solve a quadratic equation. How do you know? So this is, you really, really, really need to get this by the end of tomorrow or the end of this weekend. The sum of their squares is 260. It gave you the number. So quadratic formula or factoring, right? That's the same. If it's factorable, factor. Otherwise, use a quadratic formula. That's how you would solve this question. Take a look at the B. Compare the two. Two numbers have a difference of 14. Sum of the squares is 260. Two numbers have a difference of 14. The sum of the squares is a minimum. See the difference? Find a vertex by completing the square. You need to know which one is which. Does that help? The height of a rocket is given by this equation, where h is the height, meters, t is the time, okay? What is the maximum height of the rocket?
Vertex.
Find the vertex by completing the square. Completing the square. When does the max height occur? That's part of the vertex. You've already got that. Is everybody okay with that? Like if you're lost, you got to tell me. Because I don't know. I'll just keep going. When does the rocket hit the ground? What kind of a question is that? Quadratic formula. It's finding that. So quadratic formula. Or factoring or whatever. Right? Find the vertex. See the difference? Okay, well, I think there's one more here. Or like two more. Rectangle has a perimeter of 40 meters and has an area of 75 meters squared. What type is this? Liam. Nice. Take a look at the next one. A farmer has 300 meters of fencing. That's like perimeter. So I can use that. He's going to make a rectangular spaced area with the fencing. What dimensions would give him the maximum area? So how would I do that one? Completing the square, right? To find the vertex. Because it says the word maximum.
So whenever it says maximum or minimum,
That's exactly it. It's that easy. But people forget and don't understand how a vertex solves a problem or don't look for that. So if you are trying to quadratic formula factor something that you're finding the maximum, it is not going to go well. Okay? Okay, there's your work from a worksheet.